would have had your birthday recording for the rest of your life. You could have had that. Woohoo! Happy birthday, Giselle! We made it. Guys, clearly we're having a day this morning. It is already, I mean, it's the best day already because it's Giselle's birthday. But also, you know, we're just also having a day. So let us jump in. Can you see my screen? I can't see any of you anymore. I don't think you can see me anymore. Now.
Yes.
Can you see me?
Yep.
Could you always see me, or did I go black square for a little while?
Always.
Oh, that's awkward. I thought that I was a black screen during the other class. Interesting. Okay, I'm gonna try this other thing. I think it might be working. Can you still see my screen sharing is paused? Why is it paused?
Yep.
Don't do that. Let's see. Can you still see the thing that says Happy Bowling Day?
Yes.
Great. Okay, it says my screen share is paused, but it is apparently not paused. So I don't know, Zoom, you are like messing up here. Thank you for letting me know, Miriam. That is totally fine. What happens when I press this button? Can you still see my screen? Yes, we can. Sweet. Okay, well, today we're gonna jump in because clearly technology is not telling me any of the things I need to say. But all right, it's Giselle's birthday. We're just gonna roll with the punches. All right, so it is bowling league day. Very exciting. I don't know about you. Have you guys been bowling before? Bowling. Some of us have been bowling. I was like the coolest kid ever in high school, which is sarcasm. That's sarcasm. I was the coolest kid ever in high school, and I joined a bowling league when I was in 10th grade, mostly because I was trying to get with a boy, and he was doing the bowling league, and so I was like, I'll do the bowling league. Little did I know, I'm terrible at bowling, and so it didn't work out that well. I think I got like last place in the league, but every Saturday for like 10 Saturdays in a row, Saturday morning at like 9 a.m., I went and bowled 3 games. That's a lot of bowling if you've never bowled before. So, you know, it's been a thing. So today is Happy National Bowling League Day. It looks like some of us have been bowling, some of us have not. Just a reminder that it is Giselle's birthday. Happy birthday, Giselle. If you have not taken your attendance yet, if you could please go ahead and take 1 minute to do so. It is in the chat. Are there any questions for me before we jump in? No questions? Feeling good today? Okay, we are gonna jump in. Number one, first and foremost, I don't think this is working. Can you see, what do you see? Someone come off here and tell me what you see.
Bowling.
Bowling still, dang it. Let's see. Nope, still not working. The screen doesn't love me. Okay, how about, no, why is it doing that? It's really gonna be a pain in the butt if you can't see the notes today. That would be silly. Let's see if I can get this going. Sorry, y'all. Resume share. Go. Okay, we'll just stop altogether and try again. This is fun. Isn't this fun, guys? You guys are having fun. I just like to declare that people are having fun when I know that they're potentially not having fun, because it makes it feel like we are. Yes, we're back. All right, can people see me? I think you can, even though I can't see me. This second screen is really not feeling like it's worth it right now. Okay, you should see something that says Boo Zoom Bombers. Is that true? Great, excellent. Thank you for your head nods. Okay, so number one, I wanted to address the stuff that happened yesterday. I know that in some of your classes, some like totally hateful things were posted in the chat. Things people might have come off mute at some point during your classes. Number one, I want to acknowledge that that's probably frustrating because it is like negative for our academic space. but also more importantly, I want to notice that it's just negative for our community. I'm really happy that it has not happened in our class. I think that that's because we authenticated last week, which I know it was a little bit of a pain in the butt, but I'm glad that we did not so that no one could disrupt our space. And so I just wanted to say, like, if you've been offended or hurt by anything that has been said in the chat, I am so sorry. That shouldn't have happened. And I just wanted to continue to reiterate that that language is not okay in our class. It's not okay anywhere at Hybrid High. So I'm hurt with you, and I just wanted to put it out there. If you want to have a conversation about it, I'm happy to have that conversation, but I also don't want them to detract from our learning. So we're going to keep learning math today, which I'm really excited about. Okay. On a math note, your tests are still being graded. It takes a long time to grade online, which is like not ideal. So please hang tight. Normally I try to get them back to you within a couple of days, but they are still being graded. I'm hoping to have them graded by later today, so you can check that out. Any questions about grading for Zoom bombing? No questions thus far. Cool. Okay, you will have noticed that there were no notes today. There is just an assignment. And the reason for that is because I want to actually just like do our notes directly on the assignment. I want to make it like a little bit of an easier day today. Not that notes are hard necessarily, but I think that this will just be really helpful. I was starting to like make the notes and then I realized like, oh, I just want them to do exactly the problems that are on the assignment. So figured we could kill two birds with one stone, if that's all right with you guys. So I want to recognize that this is also very annoying that it's on the computer. So if you're working with an iPad, you're in the best case scenario because you can write on it directly. If you're writing on paper, I totally understand the struggle. So let me know if I need to go slower, faster, than whatever's happening. So you should have assignment 6 open. That will be like the easiest way to take a look. And then you'll notice throughout that there are different questions are yellow. Those are going to be the questions that we go over as a class today in our like quote notes section. So we'll do those problems together. And then the other problems are very similar, but if you have a question about those problems, then we can go through them as well. Okay. Are there any questions about the setup for today? Doing good. Cool. All right. So the first one that we are going to do is number 1. Number 1 looks like this. And we're working with function notation. This is very similar to assignment 3, concept 3, where we have a function and we have to say where that function is. In this case, it's going to get a little bit more complicated because we're going to actually do some operations with those numbers. But we will jump in, and I think you won't see that it's like too bad. So for g of x is the red line. So when it says g of 7, I'm going to find the red line. One thing that you want to see here is that if this is g of x, they're telling me that x is 7. Right? So x is 7. So on my x-axis, I'm going to go to 7, and then I'm going to find the red line, which is right here. In previous classes, I was like, oh, just estimate it. But we actually don't have to estimate here. We can see that the line is going down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, which is like 1/2, right? So really what we're doing is going down 1/2 over 1, going down 1/2 over 1, going down 1/2 over 1. So since we know that that's true, if we're trying to find 7, we can actually know that it's like right at that half mark. So it's in between 1 and 2, in between 1 and 2. So g of 7 would be 1.5. Cool. So I have g of 7 is 1.5. I'm going to bring down the minus and the 2 and the times. And then f of -7, that's the blue line. So I'm going to go to -7 on the x-axis. Here's -7. And then I'm going to go up to the blue line, and I see that there's a point here, and that point is at positive 4. So f of negative 7 is positive 4. From here, I'm just going to follow PEMDAS because I've converted everything into a number. So parentheses, I don't have any exponents. I don't have any multiplication and division. I have some, so I'm going to do that. Negative 2 times 4 will be negative 8. So I have negative 8 here, and I have 1.5. So I have 1.5 minus 8, which would be negative 6.5. Negative 6.5. That would be my answer for number 1. Are there any questions? Good. All right. Okay, cool. So let's go ahead and try number 2. Guys, check it out. I made these like awesome slides. They have the graph on every one, and then they have like just the number. I'm so proud of myself. I was like, really, really giving 110% right now. All right. So we have a slightly new notation here. This says f plus g of negative 4. If you want to think about this as 2 separate things, you can really say this is just f of negative 4 plus g of negative 4, like 2 separate ones. Some people, some like professors or like really mathy people would want you to do like the f function plus the g function at negative 4. So I'll show you both ways so that you have like a little bit of a background of that. So the first way is to break this into f, come on pencil, you can do it, there we go. F of negative 4 plus g of negative 4, like that. That's the first way of thinking about it. So I'm going to go to where x equals negative 4. Here it is. I'm going to find the f equation, which is the blue one. That's this point here. And that is at negative 2. So I'm going to write negative 2 plus g is the red line at negative 4. So I'm going to go up to the red line. Red line is here. It is at positive 4. I'm going to go ahead and put positive 4 here for g of 4. Addition says that this is positive 2, like that. Positive 2. Cool. The way that your professors will probably do it is they won't write anything down. This is like very common for some math professors, is they would say, okay, I'm looking at x equals negative 4 and I'm doing f plus g. So they would go to the graph. They would say, okay, here is negative 4. At negative 4, I have negative 2 plus 4. Negative 2 plus 4 is negative 2. And they would write their answer negative 2. They would do it all in their heads just like that. I spend a little bit more time writing it down since we're not quite at that level yet. But if you're at that level, that's okay. You can jump in. I'm sure some people are ready to go. Any questions about number 2? So if you saw something like this, f over g of 4, you would find f of 4, find g of 4, and divide them. If you see f minus g of 4, then you would do f of 4 minus g of 4, right? So that's all that notation is saying. Cool. Let us continue. Why don't we, let's take a second. Why don't you try number 7? See what you can come to for number 7, and then we'll pop back together. I'm going to give you about 1 minute. Try number 7. All right. Is there anyone who would like to talk us through this one or talk us through what you're thinking? No, that's okay too. Okay, I'll try it. So for this one, I'm going to do 4 times g of negative 12. Right? And we're going to go to negative 12 on the graph. And we're going to try to find the red equation because that is g. So the red equation I can see is like down here, but I don't quite know where it is. All right, so I'm going to go ahead. I'm going to try to figure out how I can figure out what that is. So I see that this is, if I see these points here, I can see that the pattern is like down 2 over 1, down 2 over 1, down 2 over 1. So at 10, I'm at 6, negative 6. So I'm going to go down 2 over 1. So at 11, I would be at negative 8, down 2 over 1. At 12, I would be at negative 10. So at negative 12, if I continue that line down, since it does have the arrow there, if I continue that line down, then I would get to negative 10. And so I know that g of negative 12 is negative 10. If there was a point to end the red line, so let's say instead of this arrow, there was a big point right here. If there was a point there and the line did not continue, like it actively told us that it did not continue, then we would say that this is undefined, right? Because that graph wouldn't exist, right? In this case, it tells us that the arrow makes it continue on, and so we know that there is that negative 10 there. We just need to figure out what the pattern is to get down there. So I'm still going to have my plus sign here and still times, and now I need to do f of 13. F of 13. So I see that the same thing is happening here because on the blue line now, I need to go out to positive 13. I need to find out where this is. Why don't you practice trying to figure out what that would be? Go ahead and privately chat me if you think you've got it. What would f of 13 be? Some people are saying 9. I got a few 9s here. Oh, I got a bunch of 9s here. I don't know about the final answer yet, but I've got 9 for this portion of it. Can someone tell us, could somebody come off mute and talk to us about why it would be 9? David Lopez, talk to us about why it would be 9.
Because the blue line is going up 1 over 1.
Uh-huh.
Once you reach 13, if you move the arrow up 1 over 1, it'll reach 9.
It'll reach 9. We just have to go up 1 more, right? We just have to go
Yeah.
up 1 more off the graph. And since we end the graph at 8, then the next part would be at 9. For sure, for sure. Thank you, David Lopez, sending you merit. Thanks for coming off mute. So this would be 9, right? So according to PEMDAS, we're gonna go ahead and multiply these together, negative 40, and multiply these together, 27. Someone with quick math or a calculator, what do I get? Yeah, we already got it. Final answer, negative 13. Yes, negative 13. Thanks, Kimbo. Negative 13, let's see that from there. All right. Moving and grooving. We're doing great, guys. Any questions so far? No question is stupid. All questions are great. There might be stupid questions, but we won't call you stupid for asking them. All right. Let's go ahead and take a look at 10. 10 is the backwards way. We notice that it says the values of x such that f of x equals negative 2. So remember that now they're not telling me what x is. Now they want to know what x is. My x is going to be the answer. they're actually telling me what y is. They're telling me y is -2. So on my y-axis, I'm going to go down to -2. I'm going to go ahead and just draw out this. This is where all the y's are -2. And since it says f of x, we're looking at the blue line. We want to know where the blue line hits there, and that would be at this point here and that point there. Down my pencil, come on. Who knew sometimes, who knew when you were in like 5th grade using a real pencil that you might eventually have an electronic pencil that you have to charge. Imagine if you had to charge your pencil, so annoying. All right, so -4 and +2. -4 and +2 is where we're seeing if the x value, where we're seeing it. So I would say x equals -4 and x equals 2. So when we see f of x equals a number, they're really telling us what y is. Okay. All right. All right, we're going to do the most complicated one on this page in part 1. It says the values of x such that p of x equals 7 minus f of 3 if p of x also equals x squared minus 7x. So for those of you who did the challenge a few days ago, this might look familiar, but the idea is that they're telling us what p of x is in 2 situations. And they're explicitly using the graph that they tell us, right? So f of 3, we can find that information from the graph, and then we can set those things equal to each other. So it goes a little bit like this. I'm going to find f of 3. F of 3 here is my x-axis 3. F is the blue line, so that would be this point here, -1. So I would say 7 minus, and then -1. Right, that is the 7 minus f of 3, like this. So 7 minus -1 would be 8, because the negative is positive. So now what we're saying is we did this part here, and we got 8. Right, so p of x must be equal to 8. But they have also told us that p of x is equal to x squared minus 7x. So we could say, okay, well, this must also be equal to 8. So I could write the equation x squared minus 7x equals 8. Since this has x squared and x in it, I can't just move the x over and then try to take the square root. That would be the easiest way. But since I always also have the x, I need to move everything to one side to set it equal to 0. So I'm going to subtract 8 on both sides. I would have x squared minus 7x minus 8 equals 0. Does anyone remember how to solve a problem with this? It's a quadratic, so I know it's going to have 2 answers. The easiest way is to think about factoring. There are like 5 different ways to do it. So you want to think about factoring. I need 2 numbers that multiply to get -8 and add to get -7. You guys know that?
8 and 1.
8 and 1. What kind of 8? What kind of 1?
-8, +1.
-8 and +1. Yes. So I'm going to have x minus 8 and x plus 1. I have taken the standard form and turned it into the factored form. So those are equivalent. If I multiplied them back together using the box or with FOIL, I would get back to standard form. And then I'm going to go ahead and flip them in order to find my equation. So x equals 8 or x equals -1. How comfortable do we feel with factoring? Just give me like thumbs up, thumbs sideways, thumbs down. Thumbs up, thumbs sideways, thumbs up, a couple downs. Okay, cool. Thank you for letting me know. That's good information for me. Cool. So these would be our two answers for this question here. There's like a little bit of a clue that there might be more than one answer by this parentheses S that is going to tell us that like there might be two answers because it's saying like it could be value or it could be values, which means there could be even more than two answers. There could be a bunch. Since it's x squared, there's going to be two answers. Cool. All right. So in the interest of time, I want to make sure that we are able to explore part 2. So we're going to go ahead and jump down to part 2. You guys will complete the rest of part 1, these white questions. The questions that are like in white there, those are the ones that are left for you. They're very, very similar to very similar to the ones that we did in yellow, right? So in yellow, you have those ones there. Let's go ahead and look at part 2 though. So part 2 looks like this. We're actually, instead of a graph, going to use a table, right? So instead of a graph, we're going to use a table. So we have this table here. It tells us some values for f of x, for g of x, and for h of x. And it tells us like each of these things. We're going to go ahead and look at them individually. Let me see if I have my cool slides. I do. We're going to look at number 15 and 19 so we can calculate them. So I pasted here the table so we could look at it. When they tell us this time, like h of 0, when they tell us h of 0, we're just going to be looking at the h of x line, this line down here, as well as, of course, the x values, which are across the top. So if they tell me in this case that x is 0, I'm going to be looking where x is equal to 0, but they want to know particularly the h's, right? Where's h of 0? So h of 0 would be 2. So I could say that h of 0 could be turned into 2. I have this -3 in front. Is it just like -32? What's the relationship between the -3 and the 2? You can unmute or type. Multiplication, yeah, we're going to multiply them. So I'm going to go ahead and leave these in parentheses like this. And then I have times, and then g of -3. Can someone come off mute and talk to us about how to do g of -3? How would I find g of -3?
Where the x is at, you go to -3 and you go down to g of x.
Yeah, so where it is here, if we go down to g of x, that would be right here, -2. Thank you so much, Mia. Cool, so we have -2, and then we would say, okay, this is -6 times -2 would be +12. Any questions about 15? Things you're still thinking about? Okay. All right. Our composition is what's coming next. So you'll notice something that looks different here is that we have like something inside of something else. So just like with parentheses, just like with PEMDAS, we're going to work from the inside all the way to the outside. So f of 2 is going to go first. So f of 2, I'm going to go ahead and look at the x values. X values f of 2. Here's my x value 2, and I'm going to go to the f equation, so it would be 3. So I'm going to put a 3 here. So f of 2 is turning into 3. I still have the h out here. And that doesn't mean h times 3, although it feels like it should. It really means h of 3. So now we're going to go to where x equals 3, and we're going to go to the h equation, which is at -1. So we would say h of 3 is -1. And that would be our answer for this problem. This is called composition of functions. For anyone who is a musician, you might play a composition, or someone might create a composition. It's where you take like multiple instruments and you make them all sound good together. It's like I mean, any song that you hear, those things are all like weaved together, woven together. And so like what's happening here is the numbers are being woven together, right? We're finding f of 2 and then we're using f of 2 to find h of 3, right? So that is called a composition of functions because we are composing functions together. Okay. Any questions about 15 or 19? Eric, is that coffee? I gotta get myself some. All right, cool. And then we're gonna do, the last problem that we're gonna do is like one of the more complicated problems, like the word problems that we were seeing earlier for 14. So for 25, can I get someone to read it out loud? Someone to read it out loud. Cool. Devin Aguilar Perez, can you read it out loud for us?
If p of x equals 2x minus 3, then for what values of x is p of x equals f parentheses g parentheses negative 2 closing parentheses?
Amazing. Thank you, Devin. Awesome. 2 words for how are like 2 ways that we want to say this out loud. When we see these straight lines here, we want to call them absolute value, this part right here. That's called absolute value. And then when we read this part here, I'm sorry I didn't tell you how to do this, Devin, in advance. This is f of g of negative 2. So instead of reading those parentheses out loud, we want to make sure that we're saying them like we're saying them with the word of. So f of g of negative 2. Appreciate you, Devin. Thanks so much. So we're gonna jump in. This part, it's telling us p of x is equal to 2x minus 3. So we'll leave that part. It's not giving me too many clues for right now. And then it's also telling me p of x is equal to f of g of negative 2. So again, I'm gonna start on the inside with g of negative 2, this portion here. So I'm gonna go to where negative 2 is. I'm gonna go find the g equation. That would be 1. And then f of 1. Right, so I'm gonna go to where 1 is and go to the f equation. That's at 4. My computer dropped out, huh? You guys can't see it. Yeah, bro. Thank you for letting me know, Kimbo. Yeah, thank you, Kaylin. I'm resetting. Wow, and my TV started playing. Okay, please hold. This is random. Guys, it's a ghost. Someone just turned on my TV. Very strange. Okay, we're back. It's not a real ghost. I accidentally tried to AirPlay to my TV rather than to the computer. Okay, here we go. Dun, dun, dun. So we're going to start with g of negative 2, right? So g, we're going to go to where x equals negative 2 and go down to the g equation. So it would be 1. So I'd have 1 here. And then now x is 1. So I'm going to go to where x is 1 and go to the f equation. So that would be 4. This would be 4 right here. So p of x, if I bring down p of x, is equal to 4. They told me that p of x is also equal to the absolute value of 2x minus 3. So if those two are equal to each other, if those two are both equal to p of x, they must be equal to each other. So I would say the absolute value of 2x minus 3 is equal to 4. Like that. So from here, I just have a regular equation that I can solve. I remember that the absolute value takes whatever inside, and if it's a positive number, it keeps it positive. The negative number changes it to positive. So what's in here, the 2x minus 3 could be equal to positive 4, because the absolute value of 4 is 4. Or what's in there, 2x minus 3, could be equal to negative 4. Because if this was negative 4, the absolute value would turn it into positive 4. There are two situations that we could have here. I'm going to go ahead and add 3 on both sides. 2x equals 7, or 2x equals negative 1. And then divide by 2. So I have x equals 7 halves, or x equals negative 1 half. So I have two possible answers for this one because it's absolute value. All right. I think that is an example about, each of different kinds of problems that you'll see on the homework today. I also so you'll see part 1, we went through each part of that. You'll see part 2, that will be the exact same graphs we were just dealing with. And then part 3, I wanted to give you a chance to do some extra practice if you would like to. These are exactly the same types of problems. It's just like the graph of f and x are not on top of each other. And so there are some extra practice there. It is extra credit, so you don't have to do it. You can do it if you would like to. But those are the same types of problems if you're interested in doing some more composition. I know that some people really like to check their answers with me, and I would love to check your answers. If you want to come back to my office hours, I actually start my office hours a little bit early, so you can come at 3:30 and check your answers if you want. I'll have an answer to you by then. I think that is it for me today. We can go ahead and end class a little bit early today. If you want to go through some more examples, you're welcome to. But in honor of Giselle's birthday, we will leave 4 minutes early. You guys can get it a little bit of an extra break. Are there any questions? Okay, if you'd like to stick around, you can. Otherwise, enjoy Giselle's birthday. I'll see you guys later. Bye, guys.
Bye, Miss.
Bye.
Enjoy the rest of your day. Bye.
Thank you. You too, Gally.